Okay, good morning, guys. We need to finish up. I'm just gonna stand here about 20 minutes, not more than that, and then I need to give you work to do. Yeah. As promised from last week, I said by Wednesday this week you must be able to start drawing or electronic drawings. So there's a question paper I want you to do after I finish explaining. The question paper will be posted on the WhatsApp group. I don't have a hard copy. So I'll post it to the WhatsApp group and then you can access it there. And answer some questions on question 1 and questions from question 2. I think there's only one question on question 2, which is the electronic diagram. Yesterday we discussed diodes and their uses and the types of diodes. Then I went on to discuss the schematic presentation of a diode and then rectifier circuits, because diodes are used in rectifier circuits. And I said the rectifier circuits are used in battery charging systems. So they can ask you for a 1 diode center tap transformer or a center tap transformer with 2 diodes, or the other one with 4 diodes, which is a bridge circuit. And I explained nicely, so you'll be able to answer the questions if ever I ask questions in the test or in the exam. The last 2 things I need to discuss on the electronic components are SCR, which is a silicon control rectifier. It's like electronic components as well. It looks like a diode, but the purpose of a silicon control rectifier is to regulate the flow of current. That's what you must write. Just like a diode. Okay, so we have the positive side or the anode and the cathode. The only special parts of this is that it's got a regulator. That's why I'm saying a SCR is used to regulate the current flow, meaning that it can allow current or it cannot allow current. And we said a diode can only allow current to flow in one direction, which was a junction diode, except for the Zener diode. So this SCR has got what we call a gate here on the cathode side, okay? This one is a gate, and the purpose of a gate is to open or close for current. I think you know a gate can allow you in or not. They call it a gate, but it's a terminal side of the SCR on which current is regulated. So what we do with the gates is that by automation there must be a voltage that must be applied on a gate. Because the amount of voltage that will be applied on a gate also determines the amount of current that will flow through the SCR. If a gate does not open, just imagine you want to pass through the gate but it's not open, it's locked. Will you be able to pass? No. They must be able to open for you. But how do they open the gate for you? They can either open it wide, or they can open partially, or they can not open it. So when we are saying opening the gate, in electronics, we are applying an impulse, okay? We are going to apply a voltage impulse, we call it. The voltage impulse is going to be applied on a gate. Impulse means force, you know. Apply a voltage force of different values. This thing is not done like manually. This thing is done by automation. There's a point when it can switch on, there's a point when it can switch off. So when it is off, it is not allowing current to flow. It means that it's blocking current to flow. Let's take for instance, this is connected to the supply. It's alternating current supply. Okay? Then we have a wire coming this side. And let's say for instance there is a motor here. It can be a 3-phase motor, whichever. Okay, I've just put a motor there. Then the power to this gate can be taken even from here. You can have another line bringing power to here. It's just a line. So the amount of voltage that will be going here, sometimes they can even put a resistor here. or capacitance. It depends with the sketch. But what I'm telling you is, on this gate here, which is the green line, we need to apply a certain amount of voltage. The more the voltage that will be applied on the impulse on this gate, in terms of an impulse, the more current that will flow through the SCR. The lesser the voltage applied on the gate, the lesser the current that this SCR will allow to flow through it. So where can we use? Because here we need to know the uses of SCR. Because I said it's an electronic component that is used to control or to regulate the flow of current. And I'm repeating, in regulating the flow of current, we are now looking at how much voltage is applied on the gate in form of an impulse. So how much voltage impulse are you applying here? That amount of voltage determines how much current that will pass through here to go to the motor. We know that for the motor to run very fast, we need to have more current to the motor. If you want less current, the motor will be running at a low speed. If you remember, I told you about the force on a motor, which was determined by the density times the length times what? Current. We know this formula. I said the motor theorem. The force on the motor, meaning the amount of force that will make the motor to rotate, depends on these three things. So in our situation, we are not focusing on the length of the wire or the density of the magnetic field. We are now looking at the current. In this equation, the three things, density, length, and current, are directly proportional to your force. The force down or up. That was according to Fleming's left-hand rule. We talked about it. When current is entering the motor, where is the force? The force is down. When current is leaving the motor, where is the force? The force is up. Your Fleming's left-hand rule. You have to revisit that. So my point is, the more current that this SCR allows, the faster or the more the force on the motor. You are going to apply a lot of force on the motor, and if there is more force, obviously it's going to run fast. So when we look at the uses of SCR, you must talk about light dimmers. Do you know disco lights? Or just light dimmers? Because the light dimmers is on, off, on, off, on, off. So what is causing that on and off, on and off? It's this device. Because when it's off, it means that the impulse voltage is 0 volts. When you apply 0 volts on a gate, there is no current that will pass through the SCR. Not even. When you apply 5 volts on the gate, there will be current but less current because 5 volts is less. When we apply 100 volts on the gate, there will be more current because we are saying current and voltage are directly proportional to each other. The more the voltage, the more the current that will pass through. So we are saying we use the SCR in light dimmers or disco lights. They also use light dimmers in temperature control. You know, when you are controlling the temperature, there are times you need high temperature, and then there are times you need low temperature. When we need high temperature, what do we need? More current. When you need less temperature, you need less current. And the less the current, the less the voltage on the gate. So that is the second use for temperature regulation. Third one, SCRs are used in regulating the speed of a motor, which I've already mentioned. Here is the motor here. So if you want the motor to run faster, you need more current through the SCR. If you want the motor to reduce the speed, you are going to apply less voltage on the gate and there will be less current passing through the SCR. So mention those things as long you need to regulate. Lastly, they also use it in ignition system of the car, you know, in the engine. In the ignition system of the car, we also use SCR because you are regulating the speed of your car. The more the speed, the higher the current, the more the voltage impulse applied on the gate. This is the use of SCR. Please, when you are wiring, when you do electronic circuits, arrange it in this way because this is your positive side. You can see the anode must be on the positive wave. This is a sine wave from AC power, so it means that the positive is supposed to be up, the negative down. When you draw this sine wave, you have to draw it this way. Positive, negative. Can you see it? It's telling us that this is the positive terminal, positive. Negative terminal is the bottom wire. When you are wiring this, make sure that the anode, which is the positive side of the SCR, is connected directly to the positive side of the power supply. We do have another current coming here with voltage to the impulse. That one also depends on what? That resistor. Just put it on purpose. Because if that resistor has got higher resistance, we know that the current passing through the line will be low. So they'll give you a resistor there, and then they can also include a capacitor just for extra current flow, for extra charge. If you need more current to the gate, the capacitor will release the charges in form of current to go to the gate, because current and voltage are directly proportional. So the more current we send to the gate, the more voltage we are sending to the gate, the more this will open, the more current that will go to the motor. That is silicon control rectifier. And I've mentioned the 4 uses, at least 4 of them. Light dimmers, temperature control, ignition system, speed of the motor, regulating the speed of the motor, and many more things where you need to regulate things. You need this. Just a component like a diode. That's why they say silicon control, because it's got a silicon. It's also made like a diode with positive and negative charges. Also, it has what? Silicon with it. The only difference is a gate where we regulate the flow of current. Because a diode doesn't go. A junction diode does not have a gate. But it also can only allow current in one direction. When you reverse the terminals or the polarities, then no current will flow. We talked about forward biasing and reverse biasing. Any questions? You need to ask questions. We are all fine. It's alright. We'll see. When is your test one? Is it next week or after next week? Next week. Week after, Monday. So we have a week, meaning that there's Wednesday, Thursday you practice. Monday I'll give you this chance to practice. Tuesday I will introduce production of electricity, meaning that in your test 1 I'm going to include theory, series parallel, effects of current, whatever, induction, capacitance, whatever we discussed, plus electronics. There will be electronic drawing, plus production of electricity. So it's like 3 things. You have 2 drawings and a theory question. Yeah, I know I'll be teaching production of electricity next week. So if you are writing a week after next week, it means that, we'll be sorted by then. Yes, and then we'll see the results. I'm going to go to another electronic component, which is a bipolar transistor. They call it a bipolar because it's got 2 polarities. You'll see what it means. When I was showing you a diode yesterday, I showed you a schematic sketch of a diode and I said it looks like that. It's got positive, then there's a depletion layer, and there's what? Negative. Do you recall that? It's not a bipolar, this one. Bipolar means that you are going to have 2 of these combined together. A transistor is like 2 diodes mixed together or combined together. You see the names there? We have 2 types of bipolar transistors. The purpose of a transistor is to control current flow as well. Not to regulate, to control the current flow. Meaning that it can show which path current must pass. and which path current must not pass. So I'm using the weight to control the flow of current. And then we have two types. When you are doing wiring, I'm starting with the PNP transistor before I even come to the schematic layout. I'm going to do it here. It's got a wire. One, two, three. That is I'll say PNP. Positive, negative, positive. Here, on a diode, we only have positive, positive. So if it's a bipolar transistor, we are saying we are including another piece here, another diode here. Can you see? With a positive and a negative. You see what I've done here? Two diodes together, which is PN and the PN, but the N must meet together. So where the two ends are meeting, it's the same as having a diode, a transistor this way. A transistor has got three partitions. It's got the positive, I'm talking about the PNP. Positive, negative, positive. So this central part is called a base. This first part is called the emitter. This last portion is a collector. They are wires. When I say collector wire, it's a wire that will be connected to the collector side or a collector plate. Looking at this sketch here, this is a symbol, electronic symbol of a transistor, which is PNP. What makes it a PNP is the arrow that goes into the transistor. When I do NPN, with NPN, it means that you had a diode, NPN, you're saying NPN, and then another one, NPN. Can you see them? You can even make the two, the way I did there, combine the two. NPN. NPN, you are going to have the same. This was P. We only had two. Let me just redo this one. You have NP and you have NP. Because we are using two diodes, okay? And then this is what? P. This is what? N. Bipolar. Bi means two. Okay? And then when we combine the P and the P here, can you see what I'm forming here? We are forming N, P, N from two diodes. Because we had two diodes. But this piece here is that. The sketch of NPN is not like this. It's like that, but the arrow direction is different. The NPN will be like that. There are three wires. The arrow will be coming where? Out. NPN. I am showing schematic presentation there, and I am showing you a symbol for NPN transistor. On any electronic circuit, do not use the schematic drawings. This is just to show you what's going on. The exact symbol to use is these ones. So among the three wires, 1, 2, 3, here I've given you the names. Can you see the names? Even here we have a collector, is the first one, C, emitter, the base, and then collector, the last one. The emitter is the wire with an arrow, this one, and here it's this one. Can you see? The wire with an arrow is the emitter. This is a base wire. This is a base wire. This is a collector. This is emitter. Collector. The only difference between the two is the arrow direction. Meaning that in PNP, current enters the transistor. In PNP, current must enter the transistor. When I come to this sketch, I'll do a rough sketch here. On a schematic and there as well. When we connect this positive side of a transistor to the positive side of the supply, and the negative of a base wire to then here this is a positive side of the collector connected into the negative side, positive, negative, positive. Then the negative wire of the base one connected here. Transistors must have two supplies because we're saying they control the flow of current. So one side, it must be in a reverse bias. And the one that is in forward bias is the emitter side because that is the arrow direction. You see here they were connected on the emitter side. Positive to positive. Negative to negative. So in this region here, it's in a forward bias. How is the current flow? Current is flowing like that. From positive, and current is entering what? The emitter. Check the arrow, the symbol PNP. Current enters the transistor. This is what we are doing here. Current is starting from the battery here. From the source, it enters the PNP, then current comes out here. Like that. Then there will be some current going through the positive side that will come here. Sometimes it's zero. Sometimes it's less current in here. This is reverse bias. Here it's forward bias. That's the difference. We are trying to regulate the flow of current. One side it must be allowing too much current to flow. On the other side less current. If not, zero. So in the reverse bias, there might be a little bit of current because you have reversed. Do you know that current should be flowing? You have reversed it because you have connected positive to negative and then negative to positive. It's reversed. That is the same way with the NPN. If I ask you to, before we go to those ones, this is your NPN. We have positive, the base is positive, okay? Then if we connect the wire here, we want this to be, this is the emitter. Connect your wire here, this is negative, so it must be connected to negative. We want a forward bias here. Then a positive must be connected to positive wire. Positive, negative, positive, negative. So how is the flow of current? The flow of current is from positive, so it's entering the base first. Then it's coming out of the emitter. You see, out of the emitter. Look at the arrow there. On NPN, arrow is out of the emitter. Yeah. Then on the other side, it will be reversed. This side, it will be reversed because the negative here must be connected to positive. Negative, positive, negative. And the positive must be connected to negative. That is the NPN schematic presentation. There is the sketch. Then we see. In the exam, they won't ask for these sketches. It's those two. Because we need a symbol to be put. We need to make sure that when we are inserting a transistor, they will mention to you that it's NPN or it's PNP. The difference between the two is that this one has got more charges. Can you see here? Because negative, negative. The NPN has got more electrons than the PNP. Because PNP, most of it is positive, positive, and less electrons, which is the N. This one has got more, and they like this one more than that one in the exams. They like to say it's NPN. If they just say transistor, it's up to you to use this or that. But do the wiring nicely. Wiring means that emitter, if it's positive, connect it to the positive side of the supply. We always start from the supply and see the flow current. Even it's far away from the supply, I'll follow the arrows until I get to where the transistor is, and then I connect the emitter to the supply if it's positive. In this case, my emitter must be on the negative side of the wire. You see? So what I'll do is, let's connect this one before this. Base is what? What is the base for PNP? Negative, no? What is the emitter? Positive. This is the negative. So if this is negative, you bring this wire down to the negative side of the supply. This is the positive, which is your emitter. You bring it down to the positive side. Then negative, then positive. Then the battery. And we know that current is flowing like from here into the, can you see the flow? And it is forward bias in here. Forward bias. Then we have to connect because this is not connected. On the collector plate, the collector is negative, so we have to put it in the reverse bias. Go bring this one here, bring it here, then bring it down, and it's what? Negative, so it must be to the positive. Negative, positive, negative. A base is negative, okay? Was the base negative? No, this is positive, sorry. Yeah, it's because PNP. So I'll connect to negative. First collector is what? Positive. Can you see? It's positive, connect to negative. We are trying to reverse. So it's negative, positive, negative, positive. The base is negative. It will be connected to the positive. And the flow of current, obviously, when it comes like this one will go out that way. Here, current is supposed to be flowing that way, but it's reversed because this is positive, but it's negative. This portion here is reverse bias. Okay? And when it's reverse bias, we know that there is less current in that portion. That's why it is controlling. There will be less current in that portion. That is our PNP. If I do NPN, it's the same, guys. We're just going to do this. I'll make it a bit smaller. We are saying what? NPN. And the arrow must be coming out. Can you see? This is our NPN. So we need the collector plate to be forward biased. So it's negative, bring it down to the negative side. Positive, negative, positive. This is positive, which is your base. Bring it to positive. Then now it's a negative. You take it this way, bring it to positive. Negative, positive, negative. Positive to negative, reverse. Yeah, forward bias, reverse bias. This one is NPN. Negative, positive, your base wire is this one. This one is the collector plate. This one is your emitter. Yes, guys. Where do we use this? The use of transistors is to control current flow, but mostly it is used in the amplifier system. Amplifier system, they are used to boost the power output. There is a drawing in the book that I shared with you on the WhatsApp group on transistors. Transistors are used in amplifier systems. To amplify is to boost the power output to the speakers. So it can start low, but there will be high impulse. Maybe here, the supply is low. You get high power output on the outside. So I'm saying it is used in amplifier systems. and it is used to control current flow. Research more on where to use the rectifier, these transistors, also the diodes and the silicon control rectifier. Read. Do not just depend on lectures. Listen to us, go home, open your books. That is the way to go. Because if you just depend on me explaining, you won't learn. Research. The book that is on the server, that book has got too much information. I always emphasize. Use it. It's better having too much than not. Then the book I shared with you on WhatsApp. Yes, it's a book we are using and the examiner is using, but it's summarized. You understand? It's a summarized book. So I urge or advise you to use both. Because this is how we finish electronics. Now is, do you know how to apply it in the exam? Do you know all the electronic symbols? If yes, then you can answer the question paper I'm going to give you now. I'll post it on the group. Because I can't make copies, there's too many of you, and it's better on the WhatsApp group. If you want, you can come and put on your stick. Easy. You answer question 1 and question 2. Question 2 is 20 marks, which is electronics. Question 1 is theory. Choose the questions that you can answer in question 1, because we are not done with the syllabus. So there are questions that are coming from chapter 6 in question 1. You can't answer them. But so far, everything I've taught you today, you can answer in question 1. Yes. Any questions? Easy. Okay.